So previous lecture, I kind of went from some of the early observations of Mars to just sort of the fun speculation about Martians and the War of the Worlds. But the thing is that Mars has always caught our attention. Named after the god of war, big bright thing out there that's pretty obvious in the sky that is reddish, it's different from the stars, and so it has caught attention for a long time. And the whole concept that, the basic parameters, rotation, tilt, seasons, that sounds very much like Earth, and much more so than anything else that's out there. And so it really catches people's attention. So what is Mars really like? Well, again, on the left there, we have some of these early albedo maps, albedo being the bright and dark region, of some of the features on Mars. On the right is a photograph here from Mars, about Mars. And you can see on the photograph ice caps. So you see ice caps here. You see this large dark region right there called Syrtis Major. There's some other lighter color regions and dark regions here. And so this is our basic sort of view of Mars. It has bright and dark splotches on it. So this is an albedo map showing the bright and dark regions on Mars. South is the north, north is the south is the top of that map, north is the bottom of the map, because telescopes tend to flip things upside down. All right, so this is kind of the map you would use if you were looking through a small telescope and trying to identify what you saw on Mars. On the right is actually amateur's telescope view of Mars, taken on different days and sandwiching them together to give you the idea of Martian rotation. Of course, that's how you figure out the rotation rate of Mars, is by watching that go around like that. Well, since then, we've learned a lot more about Mars. On the left is the Hubble telescope view. Okay, the average albedo is about 0.15. It reflects about 15% of the light that hits it. That's much less than Earth has. That's because there's no water, there's no oceans, there's very few clouds. The average density is much lower than Earth's average density. So that means that Mars does not have nearly as big of a core as Earth does. The average temperature ranges from a low of minus 140 degrees Celsius. That's more than cold enough to freeze carbon dioxide, which is actually the main composition of the atmosphere, up to 20 degrees Celsius, which is like a very cool day on Earth. The average temperature is about minus 23 degrees Celsius. So that is darn cold. Okay, that's like northern Canada cold. Rotation rate, just over 24 hours. Tilt, about 25 degrees. Diameter, much smaller than Earth. Again, you could fit almost 8 Marses inside of Earth. Martian orbit, much more elliptical than Earth's orbit, so 0.09 eccentricity. So it ranges from as close as 1.38 AU to about 1.67 AU. It averages about 1.5 AU from the sun. The tilt is almost 2 degrees relative to the ecliptic, so it's very close to Earth's orbit, and it's about 1.88 years. So that's just converting those days I gave you earlier into years. It does have seasons, okay, because it's tilted, then you're going to have seasons. And so you have ice caps, and in the wintertime, the ice caps get bigger, and in the summertime, the ice caps get smaller. These are images right here pieced together from satellites orbiting Mars. Now, the seasons give rise to the tilt gives rise to the seasons. Same on Mars as Earth, but remember, Mars's orbit is vastly more elliptical. So what that means is that it is so much more elliptical that the distance of the sun also affects the seasons. So, for example, at summertime on Mars, you're very far from the sun, and so it doesn't get all that warm in the northern hemisphere. Okay, whereas in the winter, you're really close to Mars in the southern hemisphere. So in the northern hemisphere, it's winter. Okay, so that means you're very close, so it doesn't get all that cold. But in the southern hemisphere, it's winter time. When you're far from the sun, that makes it extra cold. And it's summertime when you're close to the sun, and so that makes it, in fact, not quite as cold. So, okay, so not quite as warm. Okay, so rather extra warm. So that means that in the southern hemisphere, the winters are super cold and the summers are extra warm, whereas the winters are milder in the northern hemisphere and the summers are milder in the northern hemisphere. So this is one planet in which the seasons are determined mostly by the tilt, but they're also mitigated and affected by the orbital distance. In studying Mars, we want to send spacecraft to Mars. And so one of the first spacecraft to go to Mars was the Mariner 4 spacecraft, which just flew by distantly. It was a very distant mission. Mariner 6 flew by much closer, and Mariner 9 went into orbit. The Soviets sent a couple, Mars 1 and Mars 2. They didn't work right. Okay, and then Mars 3 landed and then shut itself off once it landed. And then a few years later, the Americans landed with the Viking 1 and Viking 2 spacecraft, and they worked perfectly. Vikings also had orbiters that orbited around Mars. So this was while the other missions went into orbit around Mars, the Vikings actually landed and gave us our very first up-close views of the surface of the planet. And so they landed, operated for a while, giving us up-close views, measuring the atmosphere, measuring the surface conditions. So up to that point, we didn't really know for sure. And so this was the very first landing on another world other than, for example, the moon. Now, the Soviets actually tried a lot of Mars missions. The Soviets had an interesting sort of thing here. The first thing they sent to Mars, Marsnik 1 blew up in the launch pad. And then Mars 1 launched, went towards there, and then they lost contact on the way. They had some others that they lost contact with on the way. Mars 2 crashed. Mars 3 landed and then shut itself off. And Mars 4 actually missed Mars, and Mars 5 arrived at Mars, and then they lost contact with it. And then they had a couple of them called Phobos 1 and Phobos 2. One of them quit working on the way. Phobos 2 quit working right after it got there. Mars 96 blew up on the launch pad, or actually crashed. And then they had another one called Phobos Grunt, which launched into orbit around the Earth and just stayed there. And they had many, many others. The Russians have, amazingly enough, a near perfect record with Mars. All failures. Okay. They did spectacular with Venus. Venus they did great with. Mars, not so much with. So Mars they had all kind of issues with. And now they're not the only ones. There are a lot of other missions to Mars too. One of the most recent ones, like here, for example, with the Phobos Grunt, and it failed to leave Earth orbit. Okay. Plenty of other failures, including some American failures here. Several of these were quite spectacular failures. United Kingdom, Japan, a variety of others. You know, Mars Global Surveyor, an American spacecraft, actually went to Mars and worked perfectly for several years until they had a computer glitch that actually told it to go point away from the sun and then lost contact with it. Over half of all missions to Mars from all nations have failed. Mars is a very difficult world. It just seems to eat spacecraft. And so Mars is a very difficult world to currently active. There's actually several spacecraft. Mars has been of interest for a very long time, and every 2 years there's a launch window, and so most of the time when there's a launch window, somebody sends a spacecraft to Mars, at least definitely for the last 20 years or so. And so Mars Odyssey is currently active, has been orbiting Mars for almost 20 years. Mars Express, European Space Agency, Mars Exploration Rover. Okay, that's listed as currently active. It recently quit working, so that should probably be taken off the list now. But that was a rover there. Mars Reconnaissance Orbiter, the Mars Science Curiosity rover that's currently working, the MAVEN spacecraft, Mars Orbiter mission. That's actually an Indian spacecraft that's been orbiting Mars, studying it. ExoMars is a European spacecraft which has a ride-along Russian probe with it. That one's working, and InSight, the most recent American one from 2018, actually landed on Mars. There's actually 4 more that are going to Mars that have launched in 2020 are now at Mars, and so they include another couple of American spacecraft. I would say more of those in a second. Also, China has sent a spacecraft that's going to land. Right now, it's just orbiting Mars. So it has arrived, and it's been orbiting for a while. They're not in a big rush to land the lander. They'll land when they get ready to land it. They don't want to just do it without proper preparation, so they're taking good time to do this. And then the United Arab Emirates has also launched a spacecraft, their first interplanetary mission, and so it is now at Mars and collecting data. The United States sent a spacecraft, and we sent a lander, the Perseverance space lander, which has landed safely on the surface of Mars. And the Perseverance lander has a little smaller part with it, and that's a little helicopter, like a little quadcopter drone type thing, the Ingenuity helicopter, and it is going to be the very first aircraft to fly on Mars. So far, all it's done is basically separate from the main spacecraft, but the plan is for it to fly further away from the main Perseverance rover, thus expanding sort of the territory over which we're able to study. It can fly ahead, around obstacles, and scout out the best places for the rover to actually analyze rocks, and maybe fly to places that are too rocky or too hilly or whatever, too rough a terrain for the rover to safely navigate. And so it's a significant change and improvement to our studies of Mars. There are a number of planned missions too. The United States is planning to send things in the next 2 launch windows. The next launch window is going to be the summer of 2022, and so and it takes about 9 months to get there. And so 2022, and then about every 2 years, so 2024. Likewise, European Space Agency is planning on something. Japan is planning on sending something. Russia is planning on sending one of their own, not right along, but their own separate one. If it works, it'll be the very first Russian one that actually worked. India is planning on sending something in 2024. Okay, now, I should also point out SpaceX has said that they want to send something in 2022. Now, I will also point out SpaceX said they were going to send something in 2018, and they did not. They said they were going to send something in 2016, and they did not. So they have a track record of saying they're going to send something to Mars and not yet sending it. So they're still working on it, but they do say they want to send something in 2022.